Last time we used the gas law simulation, hopefully, we found a relationship between pressure and volume, where the size of the container of the gas affects the pressure, in that if we have a smaller space, then our pressure is higher. If we have more space, then our pressure is lower. Since pressure is all about particles hitting the inside of the container, if our space is greater, we have more room for the gas, it's going to take longer for those particles to get around and hit the inside of the container, which means the pressure is going to be lower. The force is less frequent. Well, if we shrink the box, we make the volume smaller, then the gas particles don't have really anywhere else to go, and they're going to be hitting the inside of the container very often, which means pressure is going to be higher. There's going to be more force more frequently. Okay? In this case, we're going to be looking at the relationship between volume and temperature with the same simulation, again, linked here, or you can get to it on Schoology. But we're going to be looking at gas volume and temperature this time. So this should actually be 2. This should be volume and temperature. Forgot to change that when I made this. Okay, so we're looking at the relationship between volume and temperature this time. Okay, we start the simulation pretty much the same way, where we've got an empty box, so we've got a vacuum. No temperature, no pressure. Okay, without particles to hit the inside of the container and to move, to have kinetic energy, there is no good way to measure temperature, and there is no pressure. So we need to put particles in the box. So I'm going to give about 2 pumps to get my particles in there. All right, and this time, since I want volume and temperature to be changing, I don't want pressure to be changing. Now I have 2 ways I can do this, either with this pressure with a little arrow and a V, okay, or this pressure with a little arrow and a T, okay, and what that means is, am I changing the temperature to mess with the volume, or am I changing the volume to mess with the temperature? Okay, so in the case of this first bubble, I'm messing with the temperature, seeing what the volume does. In the second bubble, I'm changing the size of the box to see what happens to the temperature. Okay, so we're going to stick with this one, this top one here, where I'm going to change the temperature and see how the size of the box changes as a result. Since we want to know what the size of the box is going to be like, and at a certain temperature, we want to make sure we check off this width box. So right now our box is sitting at about 10 nanometers, and we're going to see how that changes as you kind of go bigger or smaller. So let's see on our lab if we've missed anything. Any gas particles in the box, record the data below. Okay, cool. Yep, no temperature, no pressure. Okay, we can remove particles and add particles to see what that does to the size of the box. And remember to have pressure held constant with the up and down arrow with a V, so that we're changing temperature and seeing how that affects the volume. Okay, so don't forget that you can add or subtract particles by using this little particles box on the right, using the little down arrow to remove particles. Ooh, my box is getting smaller. Okay, I can also add particles back in. My box is getting bigger. Interesting. All right. So you can answer some questions about that. Okay, yeah, we want to make sure that width is checked off. We got that. Okay, we don't have this part here because, again, we're going to be changing the temperature to see how big or small the box gets. Okay, so our heat control is essentially this little bucket down at the bottom that we can use to add in heat or remove heat. Down here. So I can add in heat by doing this. My temperature climbs. And you notice that my pressure is sticking around the same. I can also cool this down and remove heat. Cool. Now, if you run into a situation like this where your box gets a little too big or too small, then we have a hard time holding pressure constant. If this happens, don't worry, it doesn't mess a whole lot up. All you have to do is hit the X and realize that all it's changed is it's made it so that we're no longer holding pressure constant. It's so that we're allowing something to change, otherwise we're going to kind of break the simulation. Okay, so in the case of something's got to give, it's just going to let everything go so that the gas can work itself out. And so that means pressure can start changing again if we want to keep cooling it down, but our box can't get any smaller. So on the other side of that, if we want to get back to the point where we don't want pressure to change, all I have to do is click this box again and then just be careful about how big or small this box gets. Okay, so I can kind of add some more heat in and make the box bigger again. Same goes for if the box gets too big. It'll say the volume's too large. Pressure can't be held constant. Okay, well, just hit pressure again with a little V, and then I can get it to whatever size I need. Okay, so we've got a table on the backside here, okay, where we're going to be filling in the temperature it takes to get our box to be a certain size. Okay, you notice hopefully that as the box got hotter or colder, the box is getting bigger or smaller. Okay, we're going to fill in the number of particles that we have right here, and again, we're going to keep that constant through the whole thing. All right, and we're also going to make sure our box is this size to get the data here. Okay, so like I'm going to see what temperature makes the box this size. What temperature does the box have to be to get to 14 nanometers wide, or to get to 8 nanometers wide, and so on and so on. Okay, the rest of the questions kind of follow along with this, and we'll kind of test the limit of the container, shoving other stuff in there. But that's the general idea. Once you get past number 7, we are going to heat until the box can't get any bigger, and then just keep going. Okay, so that's going to be the one case where we don't go back and say, okay, I want to keep pressure constant, because we want to see just what happens as we continue to push the temperature higher and higher and higher when our box can't get any bigger. Okay, and finally, there are some conclusion questions that you can use kind of like under the simulation, your findings, to wrap up what you know in general about the volume and temperature of a gas, whether we're talking about little tiny particles or a whole bunch of particles on kind of a real world scale.